propositional logic is not enough. In other words, propositional logic cannot adequately express the meaning of all statements in mathematics and in natural language. And why? Suppose we have this statement: every computer connected to the university network is functioning properly. And if comp1, the one encircled, is one of the computers connected to the university network, does it follow that the statement comp1 is functioning properly true? Likewise, we have another statement: comp2 is under attack by an intruder. And if comp2, as you can see, is one of the computers connected to the university network, does it follow that the statement there is a computer on the university network that is attacked by an intruder true? So sadly, there are no rules of propositional logic that allow us to conclude the truth of this statement. And we can do this using predicate logic. Predicate logic is one of the more powerful type of logic, and we can see, or we will see in the subsequent lessons, how it can be used to express the meaning of a wider range of statements in math and computer science that allow us to describe properties and relations. So suppose we have the statement P. P states that X is an even integer. So this statement is just a statement, but not a proposition, okay? It is not a proposition because it neither have a value of true or false. We cannot confirm whether this statement is true or false because we don't have an assigned value for X, okay? So we say that the statement has two parts. The first part is the subject or the variable, okay? And the second part is the predicate, wherein a predicate refers to a property that the subject can have. So in here we say that X is the variable, and we can say that X can be even or X can be odd. So being even and or odd is a property that a certain variable or a number can have, okay? Suppose we denote this sentence by P of X, where P of X states that X is an even integer. Okay, so we say here that P is the predicate or the property that a subject can have, and it denotes is an even na integer, while X is the variable. Okay, this statement P of X is said to be the value of the propositional function P at X. So once we assign a value to X, to the variable X, the statement P of X now becomes a proposition and therefore will have a truth value. So we can visualize it using this way. So X is the variable that can serve as an input to P of X or the statement P of X. So once we replace the value or we assign a value to X, now this predicate becomes this statement becomes a proposition, since we can now confirm whether that statement is true or false. Okay, so let us have an example. What will be the truth value of P of 3 and P of 2? So in other words, we will replace the X with 3, okay? P of 3 is an even integer. Now, it becomes a proposition because we can confirm whether this statement is true or false. And we know that 3 is not an even integer, but an odd integer. So we can say that this statement is false, okay? So we can visualize it like this. So 3, we replace X with 3. Now we have P of 3, and 3 is an even integer. And we can confirm its truth value, and we can say that its truth value is false. And what about P of 4? So P of 4 will then be 4 is an even integer. And since 4 is indeed an even integer, then this statement is true, okay? And similarly, we can visualize it this way. So 4 will then act like an input to P of X. Okay, so we have P of 4. 4 is an even integer, and the output is a proposition, so which has a truth value of. Okay, so we can also have statements that involve more than one variable. So for instance, consider the statement X is equal to Y plus 3. And there are two variables or two unknown variables, X and Y. Okay, so we can denote this statement by Q of XY. As you can see, there are two variables where X and Y are variables and Q is the predicate. When we assign values to X and Y, it now becomes a proposition and will therefore have a true value, which could either be true or false. So we can visualize it like this. We have the X and Y that will serve as inputs to your predicate or predicate Q of XY. And then after evaluating it, you will have a truth value of either T or F. Okay. Now, given that, what will then be the truth value of Q of 1, 2, and Q of 3, 0? So Q of 1, 2, we will assign values to X and Y, replace it with values 1 and 2. X now becomes 1 and Y becomes 2. And replacing that to the statement X is equal to Y plus 3, we can now finally evaluate this statement. And we can see that it is false because 1 is not equal to 5. Okay, what about for Q of XY, where X and Y is equal to 3 and 0? Okay, replacing that to the equation X is equal to Y plus 3, it will now become 3 equals 0 plus 3. And we can say that this statement is actually true, okay? And this is supposed to be true. So this is just one way to visualize it. Okay, now let's have another example. Let A of Cn, so we have a predicate A and variables Cn. And this states that computer C is connected to network N. Okay, so assume that computer CS1 is connected to Air York, but not to network Indigo. So what will be the truth value of A with CS1 as the computer and Air York as the network? And what if CS1 is the computer and Indigo is the network? Okay, let us evaluate the first one. So let's C be equal to CS1 and N be Air York, and we will replace that to our statement. So we now have A of CS1 and Air York. Replacing that to this statement, computer CS1 is connected to network Air York. And we have stated in our assumption that CS1 is connected to network Air York. Therefore, the statement is true. Okay, and what if the value of C and N is CSI and Indigo? So we will replace that in our variable C and N and replace that in our statement, which now becomes computer CS1 is connected to network Indigo. And we have stated here that CS1 is not connected to Indigo. Therefore, this statement is false. Predicate logic for making computer programs. Okay, consider this statement. If X is greater than 0, then X is equal to X plus 1. So in other words, if a certain variable is positive or is greater than 0, then we will add 1 to its old value. Okay, so we can say that this or consider that X is greater than 0 is our P of X. Okay, and if P of X is true, then we will add 1 to x. Okay, so suppose we have x which has a value of 3 and -1. So what will happen to the program? Okay, so if x is equal to 3, we will simply replace 3 with x, simply replace x with 3. So we have p of 3 and 3 is greater than 0. Since this is true, then we will add 1 to the old value of x. The old value of x is 3. So we have x is equal to 3 plus 1. And so the value or new value of x is now equal to 4. And if x is equal to -1, then we will replace the variable with a -1 value. So now our statement is -1 is greater than 0. And since this statement is false, then we can say that, we will not perform this statement x is equal to x plus 1. In other words, we are not going to add 1 to the old value of x. So at this point, the value of x is still -1. Okay? So you can visualize it like this, like a flow chart. So we have an input or variable na x, and if x is greater than 0, then we have a truth value of true or false. And if it is true, then we will execute x is equal to x plus 1, and we will have the final output, which is the value of x. Okay, and we can also use predicates to verify computer programs. That is to show that computer programs always produce the desired output when given a valid input. Okay, so suppose we have this task and we want to interchange or swap the values of two variables x and y. So for example, if you have x equals 3 and y is equal to 2, at the end of the program, your x will now be equal to 2 and y is equal to 3. Okay, and this is one technique on how we can do that. We have a temporary variable and we assign temporary variable with the value of x. Okay, and we assign x with the value of y, and the value of y will now be equal to temp, which is the original value of x. Okay, so at that point, the x and y are already interchanged. Okay, our precondition values of x and y with a and b. Okay, so our post condition is that q of xy. So at this point, the x should now be b and y should now be a. Okay, and if the value of q of xy is true, that means that the program is working correctly. This works. So assume the precondition p of xy holds, meaning we assume that it is true. So to verify that the program does what it is supposed to do, we suppose that the statement x is equal to a and y is equal to b is true. Okay, so we are simply assigning x and y with values a and b. Remember that since our goal is to swap these variables x and y, at the end, x should be equal to b and y should be equal to a. Okay, so let us see how this works. Again, we first assume that the precondition is true. Okay, now we will check the values of variables after each step of the program. So first is that we will be assigning the temporary variable or temp with the value of x. So at this point, x is still equal to a, y is still equal to b, but now the temp is equal to a. Okay, because the value of x is equal to a. So now temp is a. Now, x is equal we assign x with the value of y. So as you can see here, the x is now equal to b. Okay, because the value of y is b and y is still equal to b and temp is equal to a. And for the third step, we assign y with the value of temp. And we know that temp has a value of x, which is a. So we can say that the y is now equal to a, and x is equal to b, and temp is equal to a. And at the end, we can check the post condition q given x and y na variables. And since x at this point is equal to b and y is equal to a, we can say that the post condition is true, or we have successfully swapped the variables or the values of x and y. So as you can see, before the values of x and y are a and b, but at this point, the value of x and y is now b and a. So you can visualize it like this. So we have the initial values x is equal to a and y is equal to b that will go through our precondition. And if it is true, then we will execute these statements. Okay. And at the end, after going through these steps or program, then we will check the post na condition. Okay. And assigning x and y with a value of that was the result of these statements. And if it is true, then the program is correct. So let's have another example. Suppose x is equal to 1 and y is equal to 5. So we will replace our predicate key of x, y with 1 and 5. So x is equal to 1 and y is equal to 5. And assuming that it is true or this precondition holds, then we will execute this statement. So temp is now equal to 1 because we assign temp with the value of a, of x, I mean, and x as a value of 1. And x is equal to 5 because we are assigning x with a value of 5, of y, which is 5, and y will now have a value of temp, which is 1. This is supposed to be 1. So now we can see that x is 5 and y is 1. And therefore, the post condition holds true.